Hello, good evening. In this talk, I'm going to tell you more than you wanted to know about writing things to a terminal, I think. When I write tabular data to a terminal, I want it to look interesting and useful, but especially I want it to look readable. And readable means many things, but one of the more basic ones for tabular data is that it is aligned and flowed in a predictable way. Doing both these things takes you to needing to know the width of a string that you're about to print before you print it. So how wide is a piece of text? If I send arbitrary text to a reasonably modern terminal, how many columns, how many cells will it use? If you need to format user-provided text in any way, you'll want this question answered. In the general case, for reasons I hope to get to explain to you, nobody knows. But we can get really, really close to knowing. The intractable part of the problem stems from the arbitrariness of user-provided strings, but also from some less-known vagaries of Unicode and from bugs and from version drift. If you use a library that ignores the problem, your tables will look bad. And all libraries I've found so far ignore parts of the problem. So your tables will look bad. You get to choose how much you care. Arbitrary text, first of all, does not mean arbitrary bytes. We need to check that we can decode it into Unicode, convert it, escape it, strip it, or fail validation. Don't accept the string. I don't care. You need to check for silly things like if a string has a combining character at the beginning. Strip it or fail validation again. You need to remove arbitrary escape sequences. If it contains arbitrary escape sequences, the only way of knowing where you end up is by implementing the terminal that you're running on. And so strip those out or fail validation. If you need to strip escape sequences to get from arbitrary valid UTF-8 to arbitrary valid UTF-8 that has no escape sequences, there is a regex that mostly does the job, but not always. Escape sequences can confuse the user and leave the terminal unusable, as well as expose some security issues. It's probably best to treat escape sequences themselves as validation errors, as opposed to hoping you can strip them. Note that escape sequences include anything from other control. So bell, backspace, horizontal tab, new line, vertical tab, form feed, carriage return, and a bunch more. If expecting multi-line strings, you'll have to handle new line and carriage return. But I'll ignore that scenario here. If it were to contain escape sequences, they should be from a limited and well-known set controlled by us, and the width of the string and the escape sequences should be tracked separately. I'm going to ignore escape sequences from here on. At this point, after stripping the escape sequences and everything else, maybe you're lucky. Where was I? Yeah. Maybe you're lucky, and what's left of the string is just ASCII, uppercase, lowercase, numbers, symbols, and space. You count the bytes, and that's the width of your string on the terminal, and you're done. Excellent. If what you have left is all European characters, and I'm being loose about what European means here, and the environ that you're running in is also European, you can probably get away with very little more work. You count the runes instead of the bytes. And that's the width of a string. This, counting the runes, is what the standard library's text tab writer does. More or less, because it strips HTML tags sometimes. Never mind. Otherwise, if you had anything more complicated than that, in Go, strings are bytes. Assuming those bytes are valid UTF-8 encoded Unicode, and a lot of Go assumes this is the case, but as I mentioned before, that's a validation issue. We can easily convert those bytes into a series of Unicode code points that in Go we call runes. All this comes built into a standard library, and it's completely insufficient for what we're trying to do. You see, Unicode characters, as in the thing the user sees, can be made up of several of our runes. For example, a family emoji has a rune for each member of the family and a rune for each of their skin tones and a few runes to tie it all into a single character. The Unicode standard calls these things grapheme clusters. So what we need to do is walk the Unicode string and look at each grapheme cluster up in a table to determine what Unicode thinks is its monospace width. You get back a number. You add those numbers up, and you get what Unicode thinks is the monospace width of the string. Anyway, those numbers can be 1 for things like plain ASCII and sometimes emoji, 2 for things like katakana, CJK, ideographs or ideographs, I'm never sure, and sometimes emoji, 3 for the triple M dash and some fancy math symbols, sometimes in theory, but today, never in practice in any usable way. 0 for things like combining characters that don't have a width on their own. And ambiguous. These characters can have a width of 1 or 2 depending on context, which in terminal means a user setting that no terminal that I know of tells you about. It doesn't tell the running program, that is. It can't tell the user. Some of them. Note that ambiguous width characters include accented ASCII and Greek lowercase. So it would be naive, and that naive has a double dot just to make the point, that even for a Western-centered shop to just ignore the problem. And yet. Anyway, some terminals like Console or Kitty or the Windows Terminal don't support changing ambiguous from anything other than 1. Some do, but don't tell the running program about it, like the GNOME Terminal. Revo's Uniseg's string width, and I'll give you a slide with exactly what I just said, does this work for us, all this work of counting. For now, this is probably the best you can do, is using that library. Unfortunately, its treatment of ambiguous is not configurable, so you'll be wrong in Japan a lot, because there they use ambiguous wide. Newer versions of rune width, Matson's rune width, use Revo Uniseg, instead of just looking at the width of the runes directly. And a lot of the things use Matron rune width. So as long as you can get them to update, you can use one of the forks of text tab writer that use Matron rune width, and there's a lot of them. Or you could use bubble T tables, which also use that. As Unicode evolves, some characters change width. Emoji used to have width 1 up to Unicode 8, I don't know if you remember. But then Unicode 9 changed them to double. In 10 and 11, some smaller width changes also happened. And in every version so far, we've had new code points and grapheme clusters. If the table you look at things up in to determine the width of grapheme clusters was written against one Unicode, but the rest of the environment, and this does not includes more things than just your Go program, the rest of the environment in which your program runs uses a different version, you get some widths wrong. And this is very common. Also, terminals have bugs and interesting design decisions. In Ubuntu 16.04, which is old but is still supported, on VTE-based terminals, which includes most of the common terminals in Ubuntu, emojis are supposed to be wide, and they do display as wide, but only move the cursor one cell. So if you write grinning face followed immediately by Latin small letter A, the A will appear to be under the face. The kitted terminal smushes a lot of graphene clusters down to 1 or 2 cells, but pads the space it uses so that some versions of the tools that measure the width will hit the right number. The ghosty terminal, which is fairly new, is a bit all over the place. It's trying to do the right thing. It's the only one I know that understands that M' should be quite wide. But if you actually try to write a M', the cursor ends up completely confused as to where it needs to be. So it's early days there. I'm told that I've not looked into it, that the default terminal on the Mac is also quite bad for these things. If you wanted to make tables with characters in the middle, you get all sorts of alignment issues there also, probably from version drift. I, as I say, haven't looked, but it's also a problem there. And not all terminals that know about Unicode can display it all. The default Linux console, that is a text mode Linux, you'll see a lot of replacement characters there if you try writing emojis and things. The thing that you get inside CI is yet another terminal, and it's got its own weirdness, and you need to consider if your tool is going to run in CI. So if you care about your users, even if you do everything right, you still need to be aware of where your tool is being used. And you need to decide which things you support. Sometimes the answer is just don't do some things. If you see the terminal isn't one of the ones you know will work, avoid printing things that you don't know if they will work on there, or if you know they don't work. So it gets quite a bit more complicated, of course. Thank you.